Hello, my name is Mohammed Shalabi, and in this video I'll be talking about relative position estimation in multi-agent systems using attitude-coupled range measurements. The main motivation behind this work is to find an approach for a group or swarm of robots to localize relative to each other in 3 dimensions in GPS-denied environments. This is important for tasks such as indoor collision avoidance or underground exploration. The problem with range measurements is that there are an infinite number of relative positions that give the same range measurements. For example, a group of robots can collectively translate or rotate about themselves as shown on the left without any change in the distance between them. In addition, in general, range measurements are not coupled to the attitude of the individual robots as you can see on the right, although robots usually do have good estimates of their attitudes to perform other tasks. In this paper, we discuss a framework that couples the range measurements with the attitude to disambiguate the relative positions. The approach is to have 2 tags on a robot, where a robot moves the distance between its 2 tags. By having 2 tags on a robot and fixing its attitude, any rotation in the swarm as a whole, as shown on the left, results in changes in the distance measurements, reflected by the change in the color of the edges. Also, if only the 2-tag robot changes its attitude, as shown on the right, this is also reflected in the distance measurements. This additional information is shown to be sufficient for relative localization of a swarm. In 3D, at least 2 2-tag agents are needed, and any number of single or 2-tag agents can then be added. This problem is shown to be observable with minimal constraints given an attitude estimate of the 2 2-tag agents is available. To validate the theory, experimental data is collected using 2 2-tag agents and 1 single-tag agent. Instead of flying quadcopters, these 2 small prototypes are built instead. These are then moved randomly in 3-dimensional space around our lab as ultra-wideband tags collected distance measurements between the agents, while ground truth data is collected using a motion capture system. This framework is shown to be capable of overcoming the observability issues associated with multi-robot relative localization in 3 dimensions, with only range measurements and attitude estimates. An accuracy of 40 to 50 centimeters is achieved using 8 range measurements, each at a low frequency of 2 Hz. Thank you very much.